This is Sachin, and welcome to Kafka Learning Session. So let's continue from our discussion from the last time. So if you have followed my previous sessions, you might be aware about how to quickly up and run Kafka in your local development environment, literally as a matter of seconds, and how to produce message, and then of course using the console consumer to see those produce message in the console. We also touched about using the Java program to produce some message. It was a simple dummy program where you just hello world kind of program where you push your message to the Kafka brokers. So today's session will be in depth and will be very interesting, I believe, because we'll be understanding producers in more details. Basically, we'll be understanding the internals of producer, which will help you to basically take a better decision based on your requirement, what kind of a producers you're going to use that. So let's quickly get it started. All right, so now you see on your screen 3 brokers, so that makes a Kafka cluster, typically broker 1, 2, and 3. And on the left side is your producer. It could be one producer, it could be like multiple producers. They are pushing the data. So these I am denoting with these messages, calling them M1, M2, and M3. All right. So now once these messages land, so let's say message 1 is going on broker 2. The first thing we need to remember, there is no leader in Kafka. Typically, if you see any cluster system, there's a leader and there is a follower. Kafka doesn't work like that. I mean, that's not truly true. What I mean is like there is a leader, but it's not a broker is a leader. The leader is always contextual. Leader is based on a data. So for example, here M1 is coming, and if M1 goes to, let's say, broker 2 in this case, so which means for this message, the broker 2 is a leader. So what does that mean? Is typically next time if the same message come, this will always land into this particular server or broker or partition. Okay, so this is one. There's no leader here. There's no overall leader, but there's a contextual leader. There's a leader based on a data. That's one. Now the second thing is there is one controller. So when your Kafka cluster is up, by default, randomly, there's one broker or server which is promoted as a controller. It has mainly 2 jobs. The first one is to basically identify or decide which message goes into which machine or which partition. And that's one. And the second one is if any failover occurs, so it just keeps a track of that. All right, so let's understand partitioning a little more in detail, though I will cover custom partitioner and how you can write your own partitioner. But for now, let's understand when you're producing these messages, M1, M2, and M3, how come M1 lands always on broker 2? So, so basically, whenever you're producing a message, and especially in case of a cluster, it's always a good idea to basically send with a message key as well. So remember, if you have followed my previous sessions, I always used to give message key as null without bothering that, because we were just trying a hello world kind of a program. We just push a message and receive it at the other end. But if you need to guarantee that the same message always land on the same machine or same partition, you need to provide the right key. And even further, you want to control that which partition, then definitely you can write your own custom partition. Probably in one of the videos, I will cover how to write a custom partitioner. But for now, just understand as long as, so once these messages are produced, M1, M2, and M3, and let's say this time you're not sending the key as null, but you're giving some key associated with that. What is the best strategy to choose a key? Basically, it's kind of your data. If let's say you're pushing an employee record, I mean, maybe employee ID could be the keys. So now what happens once you send this message, its key is taken from there, and based on that key, it lands on the broker 2. But how producer is doing that job, how it always lands the same message on the same broker. Does producer does that, or is it basically producer just dumps the data to the broker, and then internally broker decides which machine to take. So we'll understand that in more details. Okay, so before that, I just want to show you whenever we are pushing a message into a topic based on the key, it always lands into one of the partitions. So if you have already seen here message 1, based on the key, it goes to broker 2. So something like that. And what is the partition? Each partition is an ordered immutable sequence of records. So whenever you are pushing a data into a partition, so for example, M1 lands on broker 2, it's kind of Kafka internally maintains an immutable log. Basically, we call it like commit log, and everything is like a sequence. Every record, like sequentially, it gets arranged. And whenever you are pushing a record, you may in turns return an offset. So let's say you have already 10 messages in the partition. Now you're pushing the 11th one, you get the offset value. Once your record is successfully pushed, you get the response offset as a response. And actually you can see that. I'll quickly show you the sample code after that. But let's come to this diagram again, and let's understand one important concept. So how does producer internally works? So there are a couple of sequence happens when the producer pushing a data into Kafka broker. The very first thing it does is whenever you are pushing a data, basically a message which has key and the value, it serializes that key because the data needs to be passed through network. So that's one thing. Now, second, based on the key, it identifies which topic it needs to send the data. So basically, it's a producer responsibility. Before sending it to Kafka, it's a very important concept, guys. Before sending the message to the broker, the producer knows that which partition for the topic the data is going to go. That's second. Now, the third, very important point. So whenever producer is sending the data, the thread which is doing that work does not do everything end to end. Its job is to basically take a message after serializing it, identifying based on partition, either the default partitioner, which is internal, or basically you're based on your custom partitioner. It identifies which, on that topic, which partition the data will go, and it pushes that record into a batch, and that's it. Its job is over. Now, once that is done, there is a separate thread. There's another thread which actually read that batch data in the batch and pushes that into the broker. This is very important to understand because we will now, after this, we'll go to the hands-on session, and then we will understand different ways we can push that data. Of course, depending based on the requirements. So that's pretty much on the theory side, and let's quickly go to see some code. All right, so this is the same simple producer. I just tweak this method a little bit. Instead of just not returning anything, I'm just after Kafka template.send, I'm just returning the listenable future object so that I can use and print some of the values. But before everything, let's get started with Kafka. So again, if you have followed our previous sessions, you will see it's pretty straightforward. I'm just printing that command. I'm just putting that command to basically see there's no container running, and I'm still on the same directory, and I'm saying run kafka.sh. Okay. All right. Let's give a few seconds, guys. Okay, almost there. Okay, now it looks like the cluster is up and running. I'm gonna copy the producer and consumer commands. So this is my producer. Okay, topic. The only minor changes I'm going to do is here, once you run this script, you will know that it also creates different two different topics. The first topic is a normal one. With a normal command, you can create that. But this is a special topic where I have given, because it's a cluster, I can theoretically give the number of partition count to be 3, which I have given here. So this topic is basically, it's a partition topic. There are 3 partitions. So let me put this, and let's also run the consumer command from beginning. Okay, I'm gonna change my topic to test topic 2. Test topic 2. And let's quickly check whether it is running. Hey there. All right, all set up and running. And I have also changed my application properties to use my test topic. So all set. Okay, now before we go into the, executing this code, so you might have a very different requirement. Think about applications like Turbine, which produces a lot of data. Like it produces kind of a GBs of data in every day or every hour, something like that. Or basically, if let's say you are running your website and you need to capture where the user are clicking, basically to have their experience. And let's say another kind of an application where they're doing kind of a bank transaction. So there is a different requirement in different kind of an applications. And Kafka being a super flexible, based on your need, you can actually tweak that. It's a design decision, so always there is a trade-off which we will discuss. But primarily, let's understand these kind of situations where you just need to do an analysis. It's okay if few events you are basically missing out. It's okay. I mean, out of like 1 GB of turbine data, probably 50 of the records are missed. It doesn't even affect your analytics. Versus another application where there's a bank transaction, you can't lose a penny. That's okay to basically give up on latency a little bit, but the guarantee should be there. So whenever we talk about guarantee, I'm pretty sure, I'm sure I will cover the guarantee in more details, but in a nutshell, you produce records, broker stores the records, consumer consume this. We haven't touched the consumer, but in next few lectures, I'm gonna cover the consumer as well. But once you produce the record, you need, if we are talking about guarantee, let's say you can't even miss a single record. You need to guarantee that whatever producer has pushed has reached to broker. That's one. Once it reaches to broker, you need to ensure that within Kafka cluster, it is replicate thoroughly. It's not like you push the machine, you push in one of the partition which reside into one machine, and the moment you push the data and your producer response is successful, immediately the node goes down and then you lose that record, of course. Now the third part is when the consumer consumes the data, and you need to ensure that it has consumed it properly, and then you respond back to the Kafka broker that, okay, I have successfully consumed that. So we'll discuss more when we talk about guarantees. But for now, let's focus on the producer side. Depending on different application demands, you can basically have a different choices on the producer side to push the data to the brokers. Now let's quickly see that. All right, so let's go to simple producer. As said, this is a produce method. You've already seen that. I have tweaked it a little bit. Instead of just executing this line, I'm returning it, which is a listenable feature, so I can reuse that object. Okay, and this is also the same overloaded method where I'm taking key. So this key is null. Okay, that's fine. Let's come to the producer test. All right, so basically the first thing, let's see, we talked about the commit log, which is an immutable log Kafka maintains internally. As long as you are keep on pushing a message into, let's say, one partition, Kafka internally maintains the commit log. And each message, when you push, in the response, you get the offset back, which tells, okay, at which position your message has resided in that topic. Okay, so the code is super simple. It's just a test thing where I am calling an internal private method, and I'm saying, okay, push this time key is not null. And okay, one. Okay, so I'm pushing few methods, few messages, 1, 2, 3, 4, 5. Message 1 produced from Java layer sync. Just ignore that. This is important piece. Basically, this key is important. 1, 2, 3, 4, and 5. Once it comes to this method, the same key and value, I'm just calling this produce method, which internally pushed to Kafka. All right. All right, now this time, I'm not just leaving it, I'm actually getting the response back, which is a featured target. We'll quickly discuss the various different ways you can produce a message. And of course, you can get the response back. So once this result, you can actually call the record metadata and find which partition the data has gone, that's one, and what is its offset. Okay, so let's see how these 5 messages goes on. Okay, so this is my setup. Okay, all clear. Let's run that. Okay, so we see these 5 messages is being pushed, and of course our console consumer has read all these 5 messages. Now let's see what it is printing over here. Okay, message pushed to partition 0, offset 1. Okay, so we see that there are 3 partitions, 0, 1, and 2. That's what we have created. I mean, by default, if you run our Kafka setup, this topic will be automatically created for you, and it will describe that topic as well. If you want to manually create a different topic with a different name, the scripts echo is very handy. You can give your partition name, your topic name, and basically whatever configuration you want to give, as long as it is less than 3, because it's a 3-node cluster, so we cannot give more than 3 that way. So when the first message goes to partition 0, of course the offset is 1. Now we see the second message is here. Now the 5th message, basically when it goes, it lands on the same partition, and now this time offset is 2, because the last offset it has to be increased by 1. That's why it is 2. Now the second message here, it went to partition 2, and because okay, it is coming for the first time, this is 0. Why this is 1, it is not 0? Because we have pushed one message which might have gone to partition 0, and that's why it is not 0. It is started with 1. Okay, now the third message again went to the same partition 2, and of course this time offset value has come 1. And the 4th message went to the empty slot or the partition, and this offset is 0. If you want to rerun it once again, so definitely the offset will keep increasing from that point of time onwards. So okay, so you see these values are increased a bit from the point they were previously. All right, so this is one thing. Now we talked about there are various ways you can basically make a producer call. So just understand what we discussed. When we produce the record, it serializes. It identifies the producer, which partition it needs to go, and it push the data into some kind of a buffer memory. We call it batch, and that's it. Its job is done. Now another separate thread which takes that, basically once it pushes that, it gets a future object back. Now another separate thread which takes that data, pushes it into the Kafka brokers and confirms it. And if you are making a call to future.get, it actually a synchronous call. It holds your flow. It holds your execution. So that is the most level of guarantee, but it comes with the cost that your execution stops at that point of time. So basically, the 3-way if I want to call is basically the first one is just you push it and you don't care whether it is even reached to Kafka broker. So which means if I just call it like this, if I don't Let me do it like so. So let's say I have commented this for now. So this is not async, it is just like method one. So method one is like least guarantee. It just produce a message. It doesn't even know what happened, because as I said, once you produce it, you get a future object back. If you make a call to future.get, then only you'll get to know whether it was successful or not. But in this case, you're just producing it, which means after serialization, after identifying the partition, it has put that method into the buffer memory, and that's it. It doesn't even know whether that message is even gone out of your system. Let's say considering the Kafka broker is outside. Okay, so this is the least guarantee, and your execution is very fast. What kind of an error it can come if anything, something within that flow, if there is some error occurred, then only it will cause some kind of an error. But other than that, if network is not or something like that, these errors will not be captured over here. So I'm just gonna put Control Z, so we see the exact. Okay, now here it comes. So the second is like producing message in a synchronous manner. What does that mean? Is like once the first thread pushes this message, it gets a future object back. Now another thread will take this message, push it into Kafka broker, and then confirm that I am done. And that is the time the future.get execution will go will proceed further from line number from this line. And as usual, we have seen the previous method. You can basically get the partition or offset, and then I'm just printing that my message has gone successfully. So where this is useful in those kind of situations. So again, this is not 100 end-to-end guarantee, but this, if your execution is successful and you haven't got any exception, and you just successfully got an offset, which means at least one of the broker node has got this message. Now we talked about other scenario where message has reached to Kafka. Let's say one broker, one partition, one machine. What if machine goes down? All that we will discuss in more detail. But for now, we are talking about guarantees on the producer side. Okay, so if you get the response back here, which means you're guaranteed that your message has gone to broker. Now, there's another kind of situations where you don't bother about whether you don't want to hold the execution because your requirement is to push more and more data. But at the same time, you just want that if in case some error occurred while pushing your record from that buffer memory we talked about to Kafka broker, and then at least you want to log it asynchronously. And that's where this comes with a good trade-off between your speed and basically kind of getting a feedback that whether it got successful or in case it got any errors. So this happens asynchronously. Again, it's the same thing. While producing your message, you just add a callback. You add a callback for listenable future callback, and just two methods which you pretty much override on success and on failure. So this pushes is immediately the execution will go and proceed. But in case if there is an error, this line gets printed. In case of success, we are printing this particular line. So once we execute it, you see I have deliberately sleeping here for 1 second, because if I don't give, the execution will go on, the program will terminate, will not give any chance to print either of these messages. That's why there's a wait for 1 second, so which means we'll see this line happening, and then after a couple of milliseconds, probably either if it is success, you get this line printed. In case of error, this line gets printed. So let's quickly run this code. Synchronous we have already run while covering the push, so I'm just skipping it. Let's see the asynchronous flow. So let me clear my consumer over here, and let's run that. So this is not important anyway, message will be pushed because there's no error here. Message produced from Java layer in an async, so this message got printed. The important line is seeing this line gets executed first, and then this line gets executed. Okay, this is execution done for method. this is printed, and because we put a wait, it got a chance to print the success or error. So success in this case, send the message successfully with offset or whatever. So that's pretty much for today's session. I believe this is very important because sometimes we don't see what internally is happening when you're pushing a message. How to guarantee that your message, what you have produced, has actually reached to Kafka. So I hope you enjoyed this session. Next coming session, either I will cover the custom partitioner, or probably I think that can be Googled. It's like not very tough, and probably I will move to the consumer part, where whatever messages we are pushing, we can read on the consumer side in the Java layer. All right, thank you.